Alright, on to computational refocusing. So a conventional image records the irradiance on the sensor plane. This can be expressed as an integral of the radiance entering the camera through the lens, as this equation here, where F is the separation between the exit pupil of the lens and the sensor because of the irradiance falloff. EF is irradiance on the sensor plane. LF is the light field inside the camera body. And the optical vignetting cosine falloff factor has been absorbed into the definition of the light field for simplicity. So this is kind of like the same equation that we've been talking about in all these ray tracing lectures, just written a little bit differently. So if we refocus this recorded image to a different depth, this corresponds to changing the separation between the lens and sensor planes, and we can derive an equation for the image refocused to a new sensor depth F by expressing the camera body light field in terms of the original light field. So essentially we want to find some sort of transformation from our original light field to this new light field where it is refocused at a different sensor depth. And note that only the x and y coordinates of the light field are being reparameterized because we're just moving the sensor plane and not the aperture plane. So like all of our lens components stay the same, and we're just refocusing the sensor depth, so like the focusing in the image, which is why we would only modify x and y.